Good afternoon, everyone. My name is Jake. I'm with Elistair. Elistair is a French-based tether drone manufacturer. Today, we will be flying with our LIGH-T 4 tether station, integrating that tether station into an M30 aircraft. But to get things started, I'm going to go through just a quick briefing on the solution, on tether drone in general, some different applications and use cases, and we'll go from there. So with tethered drone, it is really about the endurance applications of drones in general, of being able to get to a certain geoposition, a certain altitude, and stay there for hours upon end. Some different application successes we've seen range from traffic monitoring, event protection, industrial site overwatch, basically being able to maximize all the different types of payloads and the value you can create from being at 50 meters, 75 meters, 100 meters for hours upon end, and in some use cases, days upon end. So a little testimonial here just as it pertains to the advantage of large event surveillance. So you have the site picture that you can gain from your camera payloads, all the different tracking and detection, but the actual presence of a tethered drone has been seen to act as a deterrent in many large-scale gatherings. Public safety really kind of rants and raves about if people can see that we're up there, they don't necessarily know what we're looking at, but they know that the site is being secured and being monitored. Our LIGH-T 4 station, as we have set up over here, specifically designed and enhanced for first responders, public safety, but also just some other industries as well. The system itself requires a power source, pure sine wave power. So if you have a generator inverter, or if you're on the rooftop of a building, shore power coming out of an AC outlet. The drone themselves integrates with our different modules that we offer. So we have a 6S, 8S, and 12S air module to integrate across anywhere from 40 to 50 different platforms globally. As it pertains to DJI, we have customized our air modules to make it incredibly simplistic for end users to be able to fold in the tether capability to their mission set. With the LIGH-T 4 station, we can go up to 70 meters. It's plug and play. It's designed for quick deployments, to be able to set up where you need to set up. And then when it's time to come down, pack up and head on to the next mission. As an organization, Elistair's been around and incorporated back in 2014. We've well surpassed over 50,000 hours of continual tethered flight. We have operations globally. Here in North America, we're based in North Carolina, and over in Europe, again, our headquarters is in Lyon, France. For our modules, you can see here, that's the M350. So the module offsets the left side battery, allowing our tether station to patch in and provide that continuous power to the aircraft. From there, the tether line goes down the leg, and we have a support shackle between the legs, and that allows that aircraft to receive that tether power, but also maintain its center of gravity during that long endurance flight. For the M30 that we'll be doing today, this is a good translucent picture of how it offsets the left battery. We utilize the side window on the left to connect to the actual module, which will sit up underneath the batteries on the back side of the drone. We utilize those front arms of the M30 for our support shackle. That's what carries the brunt of the tether's tension and torque on the aircraft, and vice versa as the aircraft is ascending. The LIGH-T tether station itself is contained within its own pelly case with a telescopic arm for transport, a little bit bigger than the pelly case for the M30. I like to think they're a pair, but it's a little bit larger. Incredibly easy to travel with, folds nicely into different types of command vehicles for storage, as well as quick transport. Just some different use cases of tether drone kind of around the world. Here we're kind of highlighting event security at the Ryder Cup over in France. They were flying 8 to 11 hours a day, utilizing a payload with 30x zoom and some other capabilities within there as well. From crowd control, perimeter surveillance, critical infrastructure surveillance as well. From a broadcasting standpoint, we've flown in the Alps during the World Ski Championships. Again, here over 5 hours over the course of 5 days. The broadcast quality to actually be able to live stream for a place that skies very popular like Canada, also in Sweden. Another application of Tethered drone, it's not just about persistent video capture. We've also seen the variable height antenna use case as a very popular one as well. Being able to affix different cell phone repeaters, radio repeaters, enhancing mesh network capabilities, and utilizing the tether station as your mobile pole with the ability to get that aerial robotic and corresponding payload airborne versus having to do a pole setup with those limitations that can be inherent there. Again, we had another integration with some different network carriers for rapid response connectivity exercise. We were flying 8-hour days and really kind of strengthening the actual operational success of keeping something at the altitude of 100 meters. This was another large-scale event. This one had 12-hour flights here. Again, crowd control, perimeter surveillance, things along those lines. Also seen those in fire, bringing our tethers onto sites for some structural fires, some different exercises. Here they were able to maintain vantage and basically capture the entire vent over 4 hours, including some hazmat detection as well. From a traffic monitoring standpoint, we've seen some 3-hour flights with over almost 8,000 vehicles identified and tracked. Again, being able to capture that amount of data over a time lapse, incredibly valuable to those in need of that type of data. We've also had some success with some maritime deployments. Again, dealing with sea swell and some other conditions, it can be extremely challenging. However, we were able to have over an 8-hour flight from the bed of a very, very large vessel. The piloting on that is pretty advanced. With the tether station, we're operating in a cylinder of aerospace, approximately 7 meters in diameter. So the challenge from a moving vessel is just to ensure you're keeping the aircraft in line with your speed, variable wind conditions, sea spray, and the like. This was a pretty interesting use case for search and rescue. This was a dual payload M300, I believe, with a spotlight and camera. It was deployed at a strategic location in response to a missing person. They had that up there for 6 hours through the twilight of the evening. Again, just trying to, from a technical data standpoint, the LIGH-T station can provide up to 1,500 watts continuous. We have two different tether options from a density standpoint of the actual tether line itself, a 16 gram per meter and a 10 gram per meter, specific to which particular drone you're looking to integrate with. The denser the tether line, the more power capacity that we can provide to the aircraft. The converse side of that equation is the denser means that the aircraft has more payload to carry as you're ascending. So each meter of ascent adds, in one case, 10 grams, the other 16. And it's just finding that requirement of the drone's power consumption average versus what would be the lightest way we can affix our tether. The station itself, 20 kilogram station, not very heavy. It has a auto torque tensioner. So once we get to our desired altitude, we're going to activate the auto winch, which will basically reel in and maintain any kind of slack or wind conditions that the tether line may be experiencing below where we're flying. And then as we're descending, we'll reel the tether line in for you. Just as an operator, it's something I've forgotten a handful of times as well, is if you need to ascend or you found a good vantage point and you decide I need another 10 meters of altitude, disabling that would be the best practice versus the aircraft will be able to ascend, and it just puts unnecessary strain on your motors as well as on our torque tensioner motor. But otherwise it's there, and in the event of something happening with that motor, there's a handrail to be able to assist it, or sometimes just within consumables, it's just good to have that backup of having an auto reel if need be. So what we'll be doing here for the M30 aircraft, we've gone ahead and already installed the battery lock extender. That's the black lock here. It is has two grooves. So in the event that we're not flying tethered and we just want to utilize our M30T for all the other missions that we were doing non-tethered, it has that capability, but that secondary groove will allow for our battery adapter, which is going to be seated in the front of the aircraft, to offset and be seated in there properly. We'll be flying with both of the batteries on the aircraft. So from here, we have our adapter and our module connected. We're securing the module to the aircraft via the nice side windows provided. What we'll be doing over here is connecting the tether line itself to the air module, securing that. There's a safety screw to ensure that electrical connection. We'll be utilizing the Velcro to keep the cable nice and flush to the aircraft. And then as you see the support shackle from the front arms, that's where we'll connect the O-ring from the tether line to account for the center of gravity, and all of your torque and tension will be on that O-ring versus on the electrical connection between the tether line and the air module. So we now have the aircraft and tether station configured and connected. What I did here with this tablet, once the tether station has a power source to it, it's pushing out a Wi-Fi connection that allows us to connect and monitor the system itself. It's giving us notifications here, all parameters normal. And then as we fly, we'll be tracking the power consumption of the tether station for what it's giving to the drone. So as we're flying here, just something to notice and notate with the sight picture. Those that have flown DJI platforms before are used to seeing that green bar from the moment you take off continually diminish. With what we're doing here, we're patched in. It's going to be staying there. You have your batteries that, again, they're going to simp down to a stabilized voltage between 70 and 80% over the course of the next 15, 20 minutes, and then stay there for the duration of the flight. Now that we're at our desired height, I'm gonna go ahead and turn on the auto torque, which is gonna manage the slack. We'll do a little descending so you can see as it reels itself in, and that'll conclude our demo. So as we're descending, our tether station is reeling in our line accordingly. And again, we'll go back up one more time, up to 50 feet or so. I'm just gonna go disable the tensioner before we ascend, just so the drone doesn't have to work too hard. Thank you all so much for the attention, and any questions, I'll be here. My booth's at the end. Happy to dive in a little bit more tether talk. But again, thank you all so much. Thanks to Candrone. Thank you to Adam, my pilot. Appreciate it. Thank you so much.